Alright, so this is a project log for the safety hurdle. I have redesigned most of these and most of the joints. Yeah, okay, so let's start with the simplest one. This is the easiest one. This was the easiest to redesign. It's a very simple difference. This was the original hurdle mechanism. It worked, which was great. But the client ended up wanting something with a bit more tension, so that's what we got here. This one has way more tension. It's firstly a lot more difficult to just pull down. You know, little forces won't even make it budge that much, whereas for this one, it loves to budge. It loves to move around. It also takes a lot of, relatively longer to return back to its original position. One of the big problems that we had was the hurdle. You know, since it was a collapsible hurdle, the base was flimsy. And because of that, it couldn't really support all the movement that was going on, on the top portion of the hurdle. So I redesigned the base joint, which is this part right here. Now I've just fixed these temporarily with these ring pins, but how is this a base? I'm going to show you. Just a moment. Yeah, okay. So this is going to be the permanent pin. Right now I've just put it in as a ring pin for, saving my time sake, but this is how it works. So this is what it looks like when it's folded, and then once you unfold it and then make it into the hurdle, these two holes align, and there's going to be a ring pin, like hanging here, which you can just put in like that, and then that will fix the base part of the hurdle. Now, how does this increase how does this increase, the stability? Well, for one, since this, I don't know if you can see it, but if you see this part right here, this makes, actually I have one right here. It makes this interesting integral shape. So it's not just holding it down or holding it up. It's, pushing down and pressing up at the same time. And what that basically allows it to do is there is no wobble, and I'm actually applying quite a lot of force. There is little to no wobble horizontally. So that's what it allows it to do. Also, you can't see it on camera, but there is a, in lacrosse heads, it's called a throat plug, but there's a throat plug inside here too. So that gets inserted into this hollow section of the pipe. So once you insert it, oh Jesus, once you insert it fully, there's going to be a throat plug in there that's going to make, basically this aluminum pipe and this plastic part move as one. So there's going to be absolutely no play in between those parts. And also another one, this is actually V2. There was actually a V version of there was actually a first version. It had some problems related to strength, so I redesigned this. And then this one also has, a couple of flaws. The biggest flaw here is this part. If you can see this part is becoming white with plastic powder, and the reason that's happening is because every time it folds like this little portion, which has nothing to do with, locking everything in place, touches, this joint before it locks in place like that. And the problem with that is, well, simply, once you start doing it a lot of times, it's going to, see? It's going to weather away. And obviously, we don't want this kind of weathering away, in a product that you're going to pay money for. And also, this is it also creates a lot of resistance when you're trying to piece these pieces or piece these joints together. So as you can see, there's noticeable resistance there, right? And that's really, as I said, not ideal for a product. So I've gone ahead and added a specific chamfer here that is going to remove this problem entirely by making this vertice not touch this plastic part at all. Now you might be wondering, well then wouldn't that, compromise the secureness of these two parts? No, because the secureness comes from, as I said, the ring bolt that's embedded in here, not from this flimsy plastic locking effect that I've accidentally created. Also, for the third version, which I've been modeling here, the other big difference is for version 2, I had these very slight chamfers here, and this was just purely for aesthetic purposes. But then I've decided to remove these chamfers because once you lock these in place, those chamfers actually reduce the surface area or contact area between these two pieces, and that's obviously not ideal too, but also that's, even though it's like a millimeter or two, that's still more space that we could be applying force to and making it more stable. So I've gone ahead and removed those chamfers. And yeah, so I'm going to print these out, and hopefully those are going to work absolutely perfectly, and that should be it for the base. Now for the raised hurdle part, so you remember, I'm going to actually use the same pieces here, but if you remember, there's this part, right, that goes onto one of the aluminum shafts, and then you pull this up and then it becomes the hurdle part, right? And that was the original design. I've gone ahead and modified it to do two things. Firstly, this design connected to a, in between these two tweezers, there was a plastic part, and then we had a aluminum pipe. I've gone ahead and removed the plastic pipe, so as you can see, this part is thinner because it doesn't have to hold the plastic part in between. And also, that part increases durability, but it also reduces the material that I have to use. And then the second part is I've gone ahead and changed the raised hurdle section from a rectangular pipe to a circular one. Now, I just have this carbon rod lying around, or carbon fiber pipe lying around. This is for the electronic broom project, but I do have this one lying around, and this one does happen to be 25 millimeters in diameter, so I'm going to show you it fits in perfectly. This is a bit long, so and basically what it's going to be, what it's going to look like is if you have this metal or aluminum base here, it's going to be raised like this, and then on this top part there's going to be the hurdle. You've seen it, so if you've seen it, actually I'm pretty sure you haven't seen it yet, but if you have seen it, I'm sure you know how it's going to look more or less. Yeah, so this upper portion is going to be changed to a circular pipe, and the main reason for that is to reduce play between the parts. I don't want the parts to wobble, and to do that to reduce that naturally, you basically want pipes with as little difference in thickness as possible. So that means if you have a pipe with a 23 millimeter inner diameter, you want something like a 22 or a 21 millimeter outer diameter to fit inside that, so that way it doesn't wobble as much. Problem with rectangular pipes, they're great, but the width of the pipes the width of the pipes is not something that a lot of manufacturers have a variety of options for it, especially in the lower ranges of maybe 20 or 25 millimeters. You really only have those two. So whereas if we choose circular pipes, there are a lot more options to choose from, and that allows me to reduce the play in between the parts. Yeah, so that's about it. So what I have to do now is I'm waiting for most of my materials to come. So I'm waiting on that, but I also have to cut up some of the pipes that I'm going to use because I've ordered cylindrical pipes in 1 meter length for some reason. I have no idea why I did that, but I did, so that's a problem that I have to fix now. Yeah, that's about it. Nothing too fancy. Yeah. Anyway, okay, so this is it for project log. I think it's part 5 or part 6 of the safety hurdle.